Okay, regarding actually what it concerns the malware, usually we define the category number one, which is the viruses, that's the class. And what we continue from today is the worms, the second category of the malware, the worms. So still the same constraints are to be considered, yet there is a difference between the worm and the virus. We have to recognize in order to bring the clear definition of what is a worm, which is actually a tool that can actually replicate itself and propagate over an environment by itself. The environment here is meant to be the net or the network. It's not like the virus, it has to attach itself into an application. And once the application is shared, or let's say is communicating over the network, then the virus will be spread, propagated. The worm, no. The worm by itself propagates over the network. By itself, it replicates itself. It is much more actually sophisticated in this regard, in the matter of replicating and propagating itself. And this worm, also like the virus, it has status. We talk about the worm, whether it is being executed or not. The status, they are mainly at rest, dormant, propagating, moving. Triggering means he's just doing calls and he's just launching his, let's say, execution. Execution means being in action, already active. For the what it concerns the propagation, actually, the worms do search for the entry points and the, let's say, the exit points, the in-out flow points, via which he's going to propagate. The worm by itself, yes, the worm by itself does not need an application, does not need a system in order, or whatever, it does not need a third party, let's say, tool in order to propagate. No, by itself. Yes, it has a worm. It has actually much more sophisticated and let's say competency in order to trick the system, saying and stating that it is a legitimate process. It means it can disguise a system to be a legitimate process, whatever the example is. Another example stating and let's say presenting the effect of the worm based on the time, actually capability of a worm will increase more and more to propagate, in the sense of once it is in one device, it will start infecting the nearest devices one by one. But once the time goes on, once the time is increasing, the capability and the fastness of infecting other devices in the network is much more faster. Because at the beginning we have only one copy. But later on we will have 2 copies, then 4 copies, then 8 copies, then 16 copies. So at the beginning it's a little bit slow, but once the time advances, it gets more and more spread. We take the example here. Before 200 minutes, there is a very small range of, let's say, propagation. Just after the 200, let's say 50 here, it is a sudden complete incrementation of the number of the, let's say, propagation, the influences. Time constraint here. And this behavior actually The timing is not a standard 100, 200, 300, 400. It's not a standard here. It is the example of the book is showing it to us. Yet it is to be noted that based on time, whether it is 10 minutes, 5 minutes, 1 hour, it is a matter of timing in order to start the peak of the propagation. Still examples only what they did actually and the time of the propagation, the damages caused, and see the time. This number of damages in red, and see the time only 36 hours. Uh, Technology that describes the worms, the multi-platform worm. It's a worm that can run on different platforms. It can run from a mobile. It can run upon a mobile. On a mobile, it can run on, let's say, a Windows-based operating system. It can run on a Linux operating system, Mac operating system. It's a multi-platform targeting worm. Multi-exploit worm is a worm that has a task to do. And this task is a variety of activities. Exploiting web servers, email servers, file sharing, different activities to be done. A worm, since it has the capability to propagate by itself, it is much more fast to any other malware kind. So ultra fast spreading, as we said in the explanation earlier in the graph we got it shown earlier, at a frame time, actually, a time given, suddenly the incrementation will be in peak level, uh, seen in its peak. And since the worm can replicate itself, actually, every single new worm has its own code, polymorphic. The worms are polymorphic. Metamorphos, actually, it changed its behavior. It changed actually its way of action. So it's smart enough. Metamorphic. Transport vehicles. Actually, it's a context of let's say transmission. The DDoS is one of the very famous attacks carrying commands from worms. Carrying, here when you say transport vehicles, carrying commands from worms. One important point of the let's say technology that worms do enhance is the zero day exploitation. Means it checks if a system has set its updates or not. If it has actually passed the limit of updating its environment or still did not. Zero day exploitation. Okay, from another perspective, the countermeasures versus swarms, the countermeasures versus swarms needs us to, or needs security specialists to go beyond, go behind different security solutions. Because of this only, those countermeasures, they might be actually conflicting with the antivirus techniques for malware detection, since the end user can control the antivirus how it runs. Worms can be detected in all its phases. And the worms, they do consume the resources on the network, since they are actually having the capability to propagate by themselves. The techniques and the specific techniques to detect those worms, they are mainly either we talk about signature based or filter based, or let's say payload classification based, or the rate, let's say actually limiting the behavior. Limiting the behavior. Each processor have a certain range of behavior time or use time. Yeah. Proactive, actually, it's a matter of an enormously and hyperactive worm. Means actually it is one worm that clearly is implemented to hack into a computer network. Hack it starts from a level of access only. Once you reach it to access, you started your hacking. You succeeded in the first phase. Actually, what we are seeing in front of us, actually, the kind of a worm that actually passes through different phases, actually, from the activity, from the launch, from the attack, from the triggering phase until the post execution. Different hosts, or they are actually using resources in the network, and and actually there is no order here. A worm, if it is actually running and affecting the device will be noticing that there is a high traffic is being detected, and let's say coming into and going out from the device. So this is an indicator that the device is infected with a worm, because the network traffic is being noticed in its high level. Still talking about the malicious software only, and it is not a restriction to the desktop computers, or let's say laptop computers. It's not related to that, because mobile devices and mobile frameworks, mobile digital commercialized devices, they are still concerned with malicious software, because malicious software can be implemented in different programming languages. It is not only a system related programming language. How to? How to? Because mobile devices that do enhance the major online programming languages, they do enhance web technologies, specifically you talk about JavaScript and ActiveX, JavaScript, C Sharp, or the ASP.X, all of them, they are actually representing a tool or a way via which a malware can access a mobile device. Worms can influence, let's say, impact heterogeneous platforms in the sense of Microsoft mobile. Actually, you talk about Android, then mobile, talk about iPhone, then mobile, talk about let's say Unix and Ubuntu, something like that. So a multitude of operating systems, and all of them they are actually supporting the worm as a malicious software, malicious code, or malicious program. From the concerns of the issues to lead to a successful worm attack is the input points. Starting from the client side, actually, starting from the client side, uh, the downloads is one of the very famous concerns that actually a security specialist has to consider. Otherwise, it will cause an error. It will cause actually a successful attack against you. So the download we talk. Browsers as an input and output window into the external world has to be considered also. Browsers. And from the countermeasures that has to be actually considered is the clickjacking. Clickjack actually fake links, fake clicks, robots to be yes tricked somehow. Clickjack. Other network-related issues, which are the social engineering, spam, email, Trojans. Trojans actually is the third category, and via which we see actually another software that is actually successful enough to accomplish a given task, whatever the task is. Okay. All of the three malware categories, virus and worm and the Trojan, they do have all of them. They do have actually a payload to execute. Whatever the payload is, to delete, to conceal, to hide, and so on. Okay. All of it defines actually a payload still is valid, whether it is a backdoor or whether it is let's say a backdoor that needs a trigger to be fired, something like that. All the payload as a properties we saw on the computer, digital computer still is valid. It's the same. So to answer from what we are defining here, this chapter number 6, or what we saw actually in the history with the digital course, still valid. Just to refresh your mind, a zombie is a compromised device. A botnet is a list of, is a zombie computer. Yes, zombie computers or compromised computers, and they are utilized for they're used actually to accomplish or to fulfill actually a toolkit needs. Yes, great. What actually the bots, when we say botnets or bots, when we talk about botnets or bots, there are activities to do behind. So it's a bot, Is a compromised device, zombie compromised device. What is the difference? It's the users. What are they used for? Robots. The users to do DDoS attacks, to do a DOS attack only, DDoS or DOS. All of those actually we saw them. I just passed through all of them. We saw actually the DDoS distribute denial of service, spam and send an unsolicited or unwanted emails, sniffing traffic. It's a context of uh, accessing into a traffic and transportation media, then trying to hack. Key logging. This is sort of actually a spyware along with the adware. Spreader malware. It's one of the things that has to be actually seen from within an action field. Also, botnets can be utilized to commercialize, installing advertisements, doing some games and solving issues. For the purpose of the thieving data payloads, actually they have to be seen on top of the keyloggers. Credential theft is itself. Okay. All of those actually terminologies we passed through, they are all not new for us. So in order to gain time, let's get into it. Here to countermeasure those issues as a security expert, there are considerations to be considered. Yes. Here. So actually we come to an end here. Remember the data structure here, which you can see the sparse matrix or the extended sparse matrix. Still here the same scenario. We are going to uh, yes, use actually dedicated interface in order to point different functions. And this is uh, actually can be seen at the kernel level where we can see a rootkit attack is being set into action. Rootkits, they are software, computer software. Actually, they are dedicated to infect the motherboard and the system on top of the motherboard. Here we talk about the rootkit attack and rootkit actually infection level. And here actually the rootkit what it would do, it would change the order of the sequential order inside the memory and modify the table in order to be utilized later on by the attacker itself. Uh, Usually, any malware, whatever it is, a virus, a worm, a Trojan, it has to be prevented better than detected because prevention is not yet in you. Detection, no, it is already acting and behaving inside your body. So prevention usually is primordial. Then after comes the detection, And then after the requirements for countermeasure those kinds of malware, whatever the kind is. Any questions, please? We come to an end through this unit. Any questions, please? Okay, that's great. So let's pass to chapter number 7. I'm just loading the chapter number 7, denial of service attack. Yeah. So here we are talking about the one of the malicious behaviors and one of the uh, big consideration of the cybersecurity task force, and his an endless process that would actually be available up to nowhere for now. The DOS, denial of service. Small briefing actually of what is a denial of service. It is actually a computer program that actually has to access actually environment without any consent. And this framework or this system, it might be actually a computer device, can be actually a network device, can be both, and so on. And it accesses this resource for the purpose of using its resources, but after exhausting the resource, that person in that location, the software in that location, something like that. So the DOS, the denial of service, after exploring and getting access, it would actually cause a service fail. Infects, let's say, effects of the DOS, the network traffic, the bandwidth, the resources inside the system where the attack is being happened. All of them, they would be actually infected. Okay, I'll stop at this. This is classic DOS, which is actually still DOS, still denial of service, but it is handled. Okay, I'll stop at this level. I'll stop at this level and meet you next class. And as I told you, I'll discuss with the department for the time of your quiz. And once agreed for